Up YouTube, you. Woo! Mr. King coming at you live from the studio. Here are the questions for the day. Please pause the video now and answer them. Next, grades are up to date. Progress reports are due tomorrow for teachers. And I do want to go over ionization energy. So we've been working on this with the gizmo. Ionization energy is the energy required to steal an electron. So elements with more ionization energy, they need to work harder to steal those electrons. You have to put in more energy to steal the electrons from those. I also want to give you time to finish the gizmo from Tuesday. But something to note, something a lot of people are struggling with is the last slide. So I do want to go over that. You should have gotten that electron affinity and ionization energy, on average, they increase as you go up and to the right, whereas atomic radius is the opposite. We're going to be going over why today and tomorrow. And this one, it says electronegativity increases from left to right across a row, but decreases down a column. Explain why this occurs. So I'm going to go over it a bit more in detail tomorrow, but the main reason why, it's partly because rings on the inside are stronger. So let's take argon here. Argon, very big. It's a very big atom. The strongest orbital is the inside one. That one, it'd be very hard to steal an electron from. Whereas this one is a lot weaker. It's a lot easier to steal electrons from this one. So that's why as you go up in the table, your elements are going to have more ionization energy and more electronegativity is because these orbitals are stronger. And the element is really more desperate to have these full than the outer rings full. And the reason why, so that was why when you go up, they get stronger in terms of ionization energy and electronegativity. The reason why when you go to the right, they get stronger. My right, your left. Yes. Anyways, the reason why when they're to the left, they're weaker is because elements want complete orbitals. That's when they're most stable and happy. So let's take lithium here. Lithium is on the left side of the table. It has one valence electron. But lithium doesn't want one valence electron. It would rather have a complete orbital. It wants this because the reason is this is complete and much more stable. So it prefers to lose this electron so it can be like this. But fluorine is the opposite. Fluorine has 7 valence electrons, so it is super close. It's super close to having a nice, complete ring. And that's what it really wants. So fluorine is very desperate to steal an electron so it can have its complete 8. That's the idea. So if you look at the periodic table, here are all the valence electrons by the column. So these elements over here, they're more electronegative because they really want electrons so they can get to a complete nice 2 for the first ring and then 8 for the rest of the rings. So these want to gain electrons so they can become 8 over here. That's why these ones are electronegative, is because they want to gain electrons so they become the perfect 8. These, they would rather drop back down to 0 so they can have a complete orbital. So these prefer to lose 2 electrons and 1 electron so they can have a valence electron that completes their orbital. So these ones prefer to lose them, these ones prefer to gain them because the idea is they're all trying to get a complete orbital like this or like this. Yep. So that is why it gets more electronegative as you go to the right, because these want to have a complete shell, and they need to steal electrons to get that. Yep. And then I'm going to give you some notes on the first three. So remember, ionization energy is the energy you need to steal an electron. So elements with more ionization energy, harder to steal from, and I want you to come up with an analogy for this. Try and think of something that is harder to steal from and another type of that thing that's easier to steal from. So like one of my students brought up cars. Like old cars, very bad security. So that would be like low ionization energy. Whereas new cars have a lot more security, so they're like high ionization energy. Okay? And the element with the most ionization energy is helium. Helium has a ton of ionization energy because it's very hard to steal one of these electrons because it has a complete orbital and the first orbital is very strong. So it's very hard to screw up with that. So helium's ionization energy is the highest. That's the last thing. We will finish the notes tomorrow. Okay, we'll finish all those tomorrow. Thank you so much, everyone, for sticking with me. Bye. Have a great day.